Good evening, everyone. Welcome to this webinar online talk offered by CRE. CRE stands for the Collective for Reimagining Engineering Innovation, uh, which is largely anchored by Professor Shyam Sundar from Yale and Professor Ishwaran Subramaniam from CMU. And we also have a few members from various institutions in India. It's about 1.5 to 2 years of process that CRE has gone through. And more recently, we have started this series of webinars to exchange practices and potential challenges and issues pertaining to engineering, education, and practice, involving people from different parts of the world. But the primary audience had started off with India, but as we go along in the future webinars, we will have speakers from the other parts of the world as well as audience from different parts. So for today's talk, we have the pleasure of having Dr. Shankar Venugopal from Mahindra and Mahindra. Dr. Shankar is the Vice President at Mahindra and Mahindra. He handles technology, innovation, and intellectual property related initiatives. And he is also the Dean of the Mahindra Technical Academy. And for a brief overview on Dr. Shankar, he is a prolific inventor, as well as he has done his Ph.D. from IISc Bangalore and has an executive MBA from IIM Bangalore. And he has been actively, personally, I've been interacting with him for the last 3 years, and he's very active in terms of presenting these new perspectives on design for mobility. And we are very happy to have Dr. Shankar with us to share his experience and perspectives on how the automotive industry is looking at the future challenges as well as new directions in the design for mobility products. With that, let me welcome all of you and also Dr. Shankar for this session of CRE. Over to you, Dr. Shankar.
Hey, thanks, Dr. Sudhir. Collective for Reimagining Engineering Innovation is a very brilliant initiative. I'm very happy to be speaking in this series of lectures. I, in fact, look forward to attending all the future lectures in this series too. And today I thought I will share with you some perspectives and insights on what is happening in the automotive space and what goes into designing mobility products for the future. And so friends, I have titled the topic as Reimagining Mobility, and I'm going to lay out a Desi approach to the design of mobility products. And there's a lot of excitement in the mobility space with the multiple disruptions happening, both technology and business model disruptions. And this makes it very interesting to be a product design engineer in the automotive industry today. I want to share this excitement with you and also share a few things in terms of what are the key trends to look out for and what kind of skills we would need to play an active role in building mobility products for the future. I'm currently the Vice President leading technology innovation both for automotive and farm products at Mahindra. My focus is entirely on sustainable mobility. And by training, I am a physicist and material scientist, been actively inventing all along. And prior to Mahindra, I was with Cummins, Honeywell, Dow Chemicals, General Electric, and the Indian Space Research Organization. So this is a background that I come up with. Today, I thought we could look at first the disruptions and the future mobility, what is in store, and then look at design from 4 dimensions: designing products for the customer, designing for technology convergence, designing for sustainability, and finally designing for innovation and product differentiation. Friends, I'm sure you can relate to what you see on this chart in terms of the key challenges that exist today when you look at urban mobility. On the one hand, you have vehicle tailpipe emissions and the air pollution resulting from it. On the other hand, we do see a lot of accidents that happen around us. And of course, traffic congestion, whichever city of in India you are in, day in and day out, we have to navigate through these traffic jams. So when I talk about sustainable mobility of the future, I'm basically looking at leveraging technologies and business models that can help us to build mobility solutions that are clean, safe, and also convenient. We'll start the whole discussion around these three areas and slowly we'll expand to a few other dimensions of mobility. Today, I've put my bets on three technology disruptions and one business model disruption. This is basically the electric, connected, and autonomous vehicle technologies, the three most powerful disruptions that the automotive industry is seeing today. And the fourth one is a purely business model disruption, which is shared mobility. In simple terms, the Olas and the Ubers that we use day in and day out. It's a combination of these four, which has the potential to build sustainable mobility solutions for the future. So a lot of what we talk today will be centered around these four promising areas. Electric mobility is very, very attractive for multiple reasons. Here we are talking about shifting from an IC engine vehicle to electric vehicle, which has intrinsically 3 to 4 times higher conversion efficiencies in terms of energy conversion. So the fuel economy is to be very, very high as compared to the current generation engine-based vehicles. Of course, since it's electric, there is no tailpipe emission at all. All you have to ensure is that the electricity that you use for charging your EV comes from renewable sources. Then you can be 100% sure that your vehicle is totally green. And the vehicle uses electricity instead of the fossil fuel. And there are fewer components in the electric vehicle. So all this makes it very less in terms of total cost of operation. So things can't be better than this. So everybody is really very excited about shifting to electric vehicles today. These are the real big opportunities around which the design of EV is happening today. But if you're a product designer at the Mahindra Research Valley, this is a real big paradigm shift because whenever you have opened the front bonnet of your car, you always seen the engine and many other components around it. And this has not really changed much over the last few decades. Your father or grandfather would also seen essentially the same scenario whenever they looked at what is beneath the front bonnet of their car. But today, when we talk about an electric vehicle, it's a real paradigm shift because the engine and all those components are no longer there. This is the Tesla Model S that you see here. And you don't even need that front projection. Vehicle can be fundamentally looking very different because you don't have the engine there anymore. We talk about a skateboard architecture where the battery will be on the floor of the vehicle and the motors could be hub motors. The 4 motors could be sitting on the 4 wheels. And that's it. That's the functional part of the vehicle. And the rest of it we refer to as a top hat, which is the body of the vehicle, which can sit on top of the skateboard. So design of EV is fundamentally very, very different from the design of current vehicles. It's not just the product which is getting disrupted. The entire supplier ecosystem around the vehicle is to be recreated. All these components that you see out here in this chart, the companies which have been making all these components, they have to reinvent and repurpose themselves and start supplying components for the electric vehicle, like the batteries, the motors, the electronics, the control units, and so on. So there is a very large scale disruption that's happening in the mobility industry today. So if you are aspiring to get into the mobility industry, you need to basically make sure that you are able to pick up the right skills that are needed to build electric vehicles. Everything starts with understanding the needs of the customer and making sure that our product really addresses the needs of the customer. Today, if you look at a customer who's having a IC engine based vehicle and you want to convince him to shift over to electric vehicle, the biggest concern that he or she has is around the range of the vehicle. Because all of us are so used to filling the fuel tank of the vehicle and driving very long distances. Whereas the electric vehicle comes with a battery that has a limited amount of energy, which means that there is only so much distance that you can travel, after which you have to stop and charge your vehicle. And this charging may take quite some time. So the range anxiety is one of the key factor that the customer is really concerned about today when he has to shift to electric. The next big concern is also the initial cost of the vehicle is a bit high because the battery is expensive and battery contributes to almost 40% of the cost of the electric vehicle. And the third is, of course, the way we drive into a petrol station and drive out in a few minutes. You may not be able to do this with the electric car because the charging of the electric car will take finite time. So if you are a product designer looking at designing EV products that your customers really like, you need to basically address these three facts: how you can maximize the range of the electric car, how we can minimize the initial cost, and how we can minimize the time that it takes to charge the car. As a product designer, when you try to address these needs of the customer, you'll realize that all this can be traced to one key component in the electric vehicle, which is the battery. So if you understand the battery and if you're able to innovate around the battery, then you'll be able to address all these three needs of the customer and very easily convince them to shift to electric. That's the beauty of the EV product design, because you have one key component out there which controls almost everything that the customer would like to see improved. So as a EV product designer, it's very important for you to know this battery pretty well. Don't worry about the chemistry of it. Even if you look at it as a black box, you are looking at something which can store a very large amount of energy, something which is thermally stable, which doesn't give away, doesn't lose the energy on its own over time, just keeps holding it. And it's also able to give the energy to you whenever you need. For example, you press the accelerator, quickly it should be able to give the energy to you so that you'll be able to accelerate the vehicle. It should have a low weight because you don't want to carry a very heavy battery that makes it very energy inefficient. And finally, you want the battery to be recyclable and reusable. These are the broad requirements from a product perspective if you are looking at building an electric vehicle with a very high performance. Of course, lithium-ion battery is a battery of choice today, but although we call it as lithium-ion battery, there are multiple chemistries that goes for different applications. You have the NCA, the LCO, the LMO, the NMC, all representing what are the chemical elements that goes into the chemistry of these batteries. But what is important for us to note here as a designer and manufacturer of electric vehicles, that this key component, the battery, uses certain materials that are not readily available. One is a lithium, other is a cobalt. And since these are critical materials with very limited availability, the price of these materials has been going up steadily. Today, we are at a tipping point where the cost of storing a kilowatt hour of electricity, which was at around $179 in 2018, we are somewhere around $120 today. And the day we cross $100, this electric vehicle will become economically more attractive than the IC engine vehicle that runs on fossil fuels. So we are very close to this tipping point. This $100 per kilowatt hour is going to happen in a few months from now. So it's very important for us to note the fact that once this tipping point is crossed, the adoption of electric vehicles is going to increase very, very significantly. So that's why all automotive companies are very eager to design multiple electric vehicles and get them to the market within the next 1 year time frame. More electric vehicles we make, more of these critical materials that we would need. Typically, a Tesla Model S, which has a 70 kilowatt hour battery, would need nothing less than 60 kgs of lithium carbonate. 1% increase in the penetration of electric vehicles means increase in lithium demand by about 70,000 tons per year. As I told you, these are not readily available materials. These are available only in certain parts of the globe. And we have to be very intelligent in using these materials. We have to be very, very careful about it. You would see that most of the lithium can be traced to the South American countries, Argentina, Bolivia, and Chile, and a little bit in Australia. Nowhere else. And cobalt is primarily from Congo. And most of the processing of these materials and the manufacturing of the batteries is mostly done in China. So these are the few geographical locations that are controlling the battery, which is the heart of the electric vehicle. This is a very new situation to be in, because with the IC engine vehicles, we were never in a situation like this, where there were critical materials and limited geographical availability of materials. We were never in a situation like this. So this is something totally new for all of us in the automotive industry. I'm sure many of you can relate to this image that you see here. I project this for a reason. When we talk about the price of the battery or availability of lithium and cobalt, or the lack of electric vehicle charging infrastructure in India, we are talking about so many constraints that look as if we won't be able to crack this electric mobility opportunity. So here is a story which tells you when you are faced with multiple constraints, how you can go about and still innovate and solve problems. This is a famous story of the Narsimha avatar, where there was this Rakshasa, a bad man, who got extreme powers by severe penance to the god. He wanted to be immortal. So when he asked God that, please make me immortal, God told him, everybody who's born has to die. So ask for something which I can actually grant you, ask for something more practical. So the Rakshasa asked for a few boons, which made him almost immortal. The first of which he asked that he should not die either during the daytime or in the nighttime. And God granted the boon. Second, he asked that he should not be killed by either a human being or an animal. God granted that boon also. Then the Rakshasa further asked that he should not be killed either inside his house or outside his house. He should not be killed either on the ground or in the air. And he should not be killed by any weapons known to man. And God surprisingly granted all the boons. And this Rakshasa became very arrogant and started troubling people, feeling very confident that nobody can ever kill him. So the people went back to the god and prayed to him and said, please solve this problem. Please kill this bad man and save us. So God now is looking at multiple constraints, very similar to our electric vehicle situation. How can he crack this? So he comes up with the idea. He comes up as a lion man. Top half is lion, bottom half is man. And he comes exactly at the dusk time, which is about 2 or 3 minutes when the day transitions into the night. And he brings his Rakshasa out to the doorstep of the house, which is technically neither inside nor outside the house. And then he puts him on his lap. He is technically not on the ground nor in the air. And then he, being a top half, is a lion man, so he uses his claws to kill the Rakshasa. So friends, the second half of this talk is about how we can use creativity and innovation to overcome constraints, however severe they are, and still we'll be able to crack some of the most wicked problems out there. So that's a reason I wanted to share this story with you today. So this brings us to a very powerful approach that I want to lay out to you today, which is the DESI approach to the design of mobility products. DESI is an acronym that I coined to bring together 4 very powerful cognitive techniques: design thinking, exponential thinking, sustainable thinking, and innovative thinking. So in the next few minutes, I'll systematically take you through these 4 cognitive techniques that can actually help you to build mobility products for the future. Since most of you have a very strong background in engineering design, I really wouldn't spend too much time talking about design thinking to you. You're all experts. But the one that we have been using at Mahindra very effectively, in fact, all our engineers, the moment they join Mahindra, the very first training they go through is on design thinking. And this is the human-centered design framework that we use, where we look at customer desirability, technical feasibility, economic viability, and we added a fourth dimension, sustainability, to this. And that has been the basis of our human-centered design. We also train our engineers to not only use their analytical brain, but also use their emotional heart together so that we'll be able to empathize with the customers for whom we are designing the products, and then we'll be able to build the right features into the product that will remove the constraints and pain points and really empower the end user. We do this both for the automotive and the farm products. Automotive products are typically the XUVs that you see out there. The farm products are tractors and agricultural implements. So we typically go through the 5 stages of design thinking, which is the empathize, define, ideate, prototype, and test. So since you are all very familiar with the design thinking framework, I really won't spend much time on this, but I'm going to spend more time on this next one, which is the exponential thinking part. I'll spend maximum time on that part because that is something relatively new. But all I would say on the design thinking piece is try to understand the usage pattern of the electric vehicle customers in India. Because when you talk about range anxiety, it's very easy to put a big battery and give as much range as they want. But seriously, if you think about your own usage pattern, on a typical day, you may not drive more than 50 kilometers. It's only on a weekend, a long drive, you may end up driving 300, 400 kilometers. But on most other days, you'll be hardly driving 50 kilometers. So one needs to understand the customer, their typical requirements, their driving patterns when you're designing the electric vehicle and specifically the battery capacity. Same way, you also need to understand the customer perspectives on how much cost they are ready to invest in an electric vehicle. Because the battery contributes to almost 40% of the cost of the electric vehicle. So if a smaller battery means the initial cost will be much lower. A bigger battery will really make it very expensive to start with. So it becomes very important for us to decide on the right sizing of the battery for the electric vehicles. We also talked about the materials that goes into the battery being very scarce and critical materials. So we should not unnecessarily lock up excess material in a battery. Only if you are going to drive 400 kilometers every other day, we should go for a big battery with that kind of a range. Otherwise, if you are driving typically 50 to 100 kilometers in a day, even a 200-kilometer range EV should be good enough. That's why we should have very good understanding of the customers in order to do the right sizing of the battery, which in turn controls the performance of the electric vehicle. And around charging times, fast charging stations can charge your vehicle in about half an hour to 45 minutes. And slow charging at home could be 4 hours to 5 hours. So again, you need to understand the usage patterns of your customers, their driving patterns, where they go, their typical accessibility to charging stations, and how much time they can afford to spend, and what they would like to do during the time when the car is getting charged. These are things that as a design thinker, you'll be able to get good insights by observing your customers. And that directly will lead to designing better EV products. Now let me, as I promised, I'll bring you to the exponential thinking part, which is something relatively new for most of us. So I'll spend more time on this part. So you may wonder, what is exponential thinking? For some of you, maybe this is the first time you are hearing this word. For some others, it could be something they're already familiar with. So let me again start with the story here. This is a story which is an infinitely sweet story This goes back to the days of the kings, and this is in Kerala. This king of Kerala was very fond of playing chess. So he used to invite many chess players to the court. And one day, a very wise old man walked into the court and invited the king for a game of chess. And the wise old man also demanded a very unique reward. He said, if I win this game, you should give me not gold, not silver, but just a few grains of rice. The king was surprised by this very unique demand of his visitor. And he asked him, what is it? How do you want this? And the wise man said, just give me one grain of rice for the first square of the chessboard. 2 for the second, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, and so on. The king was not used to this kind of a math, so he did a quick approximation and thought maybe about 100 bags of rice. That's fine, we have enough rice in the granary. So he goes ahead and plays the game. And as luck would have it, the king loses the game and he has to give the promised reward to this wise man. And that's when he starts doing the actual calculation of how much rice he has to give. And friends, guess what? It's not a small number. It's not 100 bags of rice. It's not 1,000 bags of rice. It's not even 10,000 bags of rice. It's a lot more than that. It's almost 2,000 times the global production of rice. Can you imagine? Gathering all the rice that's grown across the earth, and then you have to wait for 2,000 years to gather enough rice to give the reward. So friends, this is exponential behavior. You start with very small numbers, but very quickly it reaches mind-boggling, real big numbers. It's very important for us to understand this concept of exponential growth for the rest of the discussion today. So I'm going to give you a second example. So if you're taking one step, and that one step is about a meter, pretty big step. And if you take 30 such steps, you'd be at the most 30 meters away from where you started. Whereas if you take 30 exponential steps, where you keep doubling the step, 1 meter, 2 meters, 4 meters, and so on, for the same 30 steps, you would have gone around the world about 25 times. Can you imagine? It's not just once or twice around the world, but 25 times you would have gone around the world in just 30 exponential steps. So let's take a pause here to think about this and recognize the fact that exponential is something which is very new for all of us. We have been living in a linear, incremental world for many years, but now we are getting into a non-linear world where things are growing exponentially. It's no longer incremental. So that's why we need to start thinking exponentially, in the sense when we set ourselves to improve things, say for example, the fuel efficiency or safety or anything for that matter in a mobility solution, it's no longer imagining a 2x improvement or a 5x improvement. It's about targeting a 10x or a 100x, and if you're bolder, even a 1000x improvement, because that's a world that we are getting into. Let me show you some evidences of how it is happening today. Those of you who have a background in electronics and semiconductors will be able to easily recognize this plot, which is the Moore's law. What Gordon Moore predicted was the computing power of the chip would double every 18 months, and the cost of computing would halve every 18 months. And we have seen this happen. This is the data that shows you over 30-year time period how the computing power has continuously doubled. So you may recognize that the y-axis is actually a logarithmic axis. That's why we are able to show this very large increase in a small frame. We are all the beneficiaries of this exponential growth in computing power. For many years, for the kind of computing power that you have in your smartphone today, we'd have required a supercomputing center with 10 floors with computers, very high performance computers consuming a lot of energy and cooling and whatnot. But today you are able to carry that much of computing power in the form of a smartphone, which many of us are able to afford. And it's so small and compact that we are able to carry it around everywhere. But even 20 years back, this would have been a multi-storied building, not a small compact device. And it is not just one technology which has been growing exponentially. There are multiple technologies like the mobile internet, the cloud, the IoT, renewables, energy storage like the lithium-ion batteries that we talked about, advanced robotics, AI and machine learning, advanced materials like graphene and composite materials, next-gen genomics, oil and gas exploration and recovery, autonomous and semi-autonomous vehicles, and advanced manufacturing like the 3D printing, the additive manufacturing that we are all very familiar with. There are multiple such technologies which are growing exponentially. So this is a McKinsey study that had identified the 12 most potentially economically disruptive technologies. That's why I have put these alone here today for the discussion. You as a product designer will be using more than one of these technologies in your solution. And the best part of it is all these technologies are growing exponentially in their performance, and the cost of these technologies is falling exponentially. Let me show you what it takes, what comes out when you put a bunch of technologies like this together. So this is called Oli. Oli is electric vehicle. It's an 8-seater minibus, and it's very lightweight. It's mostly made of composite materials, and almost 90% of Oli was 3D printed, and it took less than 12 hours to 3D print this entire vehicle that you see here. And Oli has been on the roads for more than 5 years, the Gen 1. Now the Gen 2 also has been launched. As I said, it's electric, connected, and also autonomous vehicle. So there is no driver, but it can navigate through dense traffic in the city. But what is even more interesting is there is no onboard intelligence on this vehicle. There is no powerful computer sitting on this vehicle and driving it. The way it happens is there are cameras and very basic sensors which capture the information, the environment around this vehicle, and sends this information to IBM Watson on the cloud. So Watson analyzes this information and instructs this vehicle to either accelerate or brake or turn left or turn right. With this arrangement, this vehicle can actually navigate through density traffics. That's a beauty of technology convergence. Friends, how many of us are really ready to use multiple technologies like this into the kind of products that we are designing? What it means is whether you are a mechanical engineer, electrical or electronics engineer, whatever be your domain, you need to be having a functional knowledge of all these exponentially growing technologies so that you can mix and match them in your product design. So that once you do that, you'll be able to create exponentially growing value to your customer. So we are talking about technology convergence. Each of the technology which is converging is exponentially growing. So you can imagine when multiple such technologies come together, the kind of value that you can create for your customer. So friends, it's very important for us as product design engineers to familiarize ourselves with all these technologies and design products that bring multiple technologies like this together. This is very, very important going forward. And I want to introduce you to the very powerful 6D framework of Peter Diamandis when you want to use these exponential technologies in your product design. So as a product designer, the very first question that you need to ask yourself is what is still not being digitized in the product and the service that I'm offering? And how can I digitize and thereby create better value for my customer? So when you ask this question and start your journey, invariably there will be an initial phase, what we call as a deceptive phase, where you may not see much happening. And you'll be wondering, did I take the right decision? Will really digitization lead me to exponential value? But here you have to be very patient and cross this phase of deception. Then you will see the disruption happening. A clear evidence of that is what we call as dematerialization. You remember that picture that I showed you, that there is nothing beneath the bonnet, the front bonnet of the electric car. So dematerialization is that phase where physical objects, components, subsystems just vanish because of the technology disruption. So that's a clear evidence that you're already hit the exponential part of the curve. Once dematerialization happens, the natural next stage is demonetization, because you're knocking off the material cost, manufacturing cost, all that associated with all those components, and you are talking about bringing in the power of digital technology. And once it's a digital, you remember the Moore's law, which is the exponential growth that comes along with the digital. Finally, all this leads to empowering you as a product designer to democratize your product. By this, what I mean is the product that you are building using cutting edge technologies will actually become very affordable and accessible to every single person out there. That's the beauty of this whole 6G framework. All you have to do is start with digitization, survive through deception, be patient enough during the difficult phase. Then you will witness disruption, dematerialization, and demonetization. So finally, as a product designer, you will have the satisfaction of creating a well democratized product which is affordable and accessible to all. That's the beauty of this entire exponential thinking journey. We talked about design thinking, we talked about exponential thinking. So this is only the first half of the Desi approach. I have two more important aspects to discuss with you. The third is the sustainable thinking. This is very important in the context of EVs. Because I told you that the lithium and the cobalt that goes into the batteries, these are critical materials, not readily available. So when I started my own research in this area, I started with using a very powerful tool called system dynamics modeling, origins from MIT, to predict the kind of future scenarios that demand versus supply for these critical materials, lithium, cobalt, and even the rare earths for the magnets, the permanent magnets of the motors of the EVs, so on. And this model was created about 4 years back. The last 4 years, this model, we have continuously refined it so that we are able to very accurately predict future scenarios in terms of demand for these materials and how we should manage the supply of these materials. So this is a very small beginning that we had in terms of looking at how to make this whole EV very sustainable. Then we also looked at how we can actually recycle and reuse the batteries that goes into the EVs. So there are companies like the Redwood Materials who claim that they can almost recycle 90% of the materials, the lithium, cobalt, nickel, manganese that goes into the batteries. So friends, as EV product designers, it's very important for you to design the battery pack in such a way that it is very easy to recycle and reuse. This is very important. Of course, geographically it is limited, but if you look at deep sea mining, there are parts of the ocean which are very rich in some of these critical materials. So today it is possible to look at deep sea mining in an economical manner and really access some of these rare materials. To the extent that we have this blue economy, and the Prime Minister Modi, when he shared his vision of the blue economy, he in fact said that the blue chakra or the wheel in the India's national flag actually represents the potential of the blue revolution or the ocean economy. That's how central this whole idea is for our growth going forward. The next is the space. There are asteroids which are very rich in some of these metals and minerals. So one need not be constrained about the availability on Earth. Apart from looking at the sea, we can also look at the space. And for example, this asteroid 16 Psyche could be worth about 14,200,000 trillion dollars. Look at it, what all it has. You name the material, it has all those. And there are startups which are well funded, which are seriously pursuing technologies of this kind. So going back to our Narsimha Avatar story and the constraints, just remember, don't get constrained by the availability of battery materials or motor, the rare earth materials or the electronic materials, because once you start thinking in terms of abundance, once you start looking at alternative sources of these materials, you'll never be constrained by their availability. You'll be able to really come up with world-class EV products without ever being constrained by any of these materials supply. Interestingly, about a month back, we did announce that we found lithium in India, not just a teeny weeny amount, but a very large amount of about 5.9 million tons of lithium in India. Because earlier I told you lithium was there only in Argentina, Bolivia, Chile, and Australia, but that's not the story today. We have good amount of lithium in India too. And of course, we have the rare earth elements too. This is in Andhra Pradesh in Anantapur. This is very close to the place where I did my master's in physics. This was at Satya Sai University in Puttaparthi. I was there for doing my master's. It's in that same region that rare earths, about 15 different rare earth elements have been found. And so this goes into building the permanent magnets that we need for the motors in electric vehicles. So between battery materials and motor materials, I think we are in a relatively a good situation to be in. So sustainable thinking is all about looking at material availability, looking at the impact on the environment, because as we mine these materials and process them and purify them, we should make sure that we are using environment friendly processes to do this. If one of these elements is not environment friendly, then we should look at alternative chemistries and newer designs that would make it sustainable. So as product designers, it's very important for us not to let go the focus on sustainability. This is super important. So having talked about design, exponential and sustainable, the last part of this discussion today is on creating products that are well differentiated through innovation. Okay, because for a long time, product differentiation was more through the cost, but today it's very critical that we use innovation as a key product differentiator. So I'm going to lay out a couple of simple tools that can help you to come up with innovative ideas. And this is the fun part of this whole talk today. This is going to be a more interactive exercise that we are going to do today. I just have a couple of tools which can help you to come up with innovative ideas, because the designers, the product designers, are generally the most innovative people. But I have seen that even sometimes we run out of ideas, and this is where these tools can actually help us. So look at these 4 blocks that I have. You may wonder what this is all about. So let me very quickly illustrate to you how you can use this. So you can see me that I'm holding a pen in my hand, and the noun is pen and the verb is write. So if I'm making a pen, if I'm a company making pens and I make pens for writing, I'm in the red box. But when I move to the green box, which is same noun, different verb, where I make pens, but it's not for writing, it's find some other alternative applications. So here is where you start thinking about what else can you do with a pen other than writing. This is basically diversification, finding new applications for your product. This is very rich because once you get into this mode, you'll be surprised at how many newer applications that you can find for your product. The third block, the yellow block, is basically you want to write, but if you don't have a pen, what else can you use to write? This is basically finding out who else can disrupt you, because their product also can do the same job. The verb is the same, although the noun is different. So this is kind of preempting your competition and trying to figure out who can possibly disrupt you. And the fourth block, which is a different noun and a different verb, it's not a pen, you're not writing, but still you're getting your job done. which is getting the message across, sharing information. This is where you look beyond writing. How else can you get the message across? These are this is the block where you get disruptive ideas and your product looks very different from your current generation. This is where a lot of the real disruptive innovation happens. So whatever be the product that you are designing, whatever be the industry you are in, if you systematically run through these four blocks, you'll be able to expand the application for your product. You'll also be able to predict who could potentially disrupt your product. And also you could come up with the next gen version of your product in a very easy and systematic manner. So this is a divergent thinking tool, which is called the noun and the verb. So we have a few more minutes, so I will lay out to you a couple of more techniques. So if I'm asked to solve a problem, typically I would think like Shankar and I will solve the problem. It's very difficult for me to think like Sudhir or Sham or Umang. It's very difficult to think like somebody else. And that's how all my ideas are kind of stereotyped. Every time I think like Shankar, so I get the same kind of ideas again and again and again. But is it possible for us to think like somebody else? For example, if I'm designing an electric vehicle for Indian markets, if I ask myself, what would Steve Jobs do? How would Steve Jobs go about designing this vehicle? Or what would Sherlock Holmes do? What would Superman do? What would Yendiran do? Rajnikant. Imagine if Rajnikant is designing an electric vehicle, how would he do? Or if a robot is designing and building an electric vehicle, how would the robot go about it? And of course, if a child is asked to design an electric vehicle, how would she go about designing an electric vehicle? Remember, friends, these are ways in which you can overcome your constraints, your limitations, because typically we have this analytical brain and the creative brain. Whenever the creative brain tries to think differently and offer a new idea, the analytical brain will try to analyze and kill it. So this is one way where you can bring some variety into your thinking by just asking yourself, if somebody else is doing this job, how do you think they would go about it? Because Sherlock Holmes, we know he'll always he'll observe things carefully, he'll find the root cause and try to address things. Steve Jobs would focus more on what you call as design elements and understand the customers, what they need, and use the power of digital technology to bridge this, and what we call as intuitive design, which is what the Apple products are well known for. And Superman can literally do anything. He's a Superman, so there are no constraints. Absolutely, he can do anything. And so is with Rajnikant. And when we talk about a robot, we talk about bringing in a very high level of automation to this whole space, which is what the Industry 4.2, the new manufacturing plants, even at Mahindra in Chakan in Pune, is entirely automated. So you can look at the power of bringing robots to a manufacturing environment. Today, the EVs can be made in a very small space. The size of a tennis court is what some of the EV manufacturing plants look like. In such a small space with a very high level of automation, you can build electric vehicles. Of course, what would a child do? The child has no inhibitions. There is no knowledge that actually constrains her thinking. So she'd be most creative among this whole lot in terms of imagining how the future EVs would look like. And this is a framework and a fun tool that I created way back in 2011. So it's almost now 12 years that I have been using. And I have a deck of more than close to 200 such characters. And whenever I run out of ideas, I randomly pull out one of these cards and try to imagine how they would solve this problem. And this approach has always led me to some very interesting out of the box ideas. So with this, just one more tool I want to share before we wrap up. This is, you have ideas. Now when you want to really implement them, many times you find that you don't have the resources that you need. And that's where you get stuck. So I thought this tool could be useful to you. We call it as WIN, which is what if it's not there? This is a very real life situation when it comes to implementing your innovative ideas. So let me illustrate. Suppose somebody asks you to create a very innovative design of a school. Basically, you'll make a few assumptions that the school would need a teacher, school would need a building, you need to conduct exams, and of course, you would need students. Now, a win school, which is what if it's not there, basically would make you challenge these assumptions and ask, if there is no teacher, how can I run my school? If there is no building, what else can I use to run my school? If I can't conduct exams, how else can I evaluate? If I don't have students, whom else can I teach? So look at the pictures here. You have schools where when you don't have a teacher, maybe the students are just learning from each other, or learning from the seniors teach the juniors, or you have a robot teaching them, or all of them are looking at some videos and learning together. Variety of things that can happen when the absence of a teacher. But friends, you also recognize that you can supplement the teacher with all of these things and make this school a very innovative and a fun experience to be in a school like this. Of course, if you don't have a building, you can run the school under the shade of a tree. You can run it in a boat, a bus, a train, many such options. No exams, that's nice. A lot of us would like to be in a school like that. Then you can have a continuous evaluation and projects and seminars and whatnot. The last one, where you don't have students, you're asking yourself, whom else can you teach? So maybe you can teach the parents, you can teach the teachers, we can look at who else can benefit from this infrastructure and the knowledge that is available in the school system. The way this tool works is you reverse the assumptions, you generate some ideas, take these ideas, put them back in the original system where there is a teacher, a building, exams, and students, and add these ideas over and above the existing thing to make it very innovative. So this is what will come to your help when you find that some of the resources that you need for implementing your idea actually doesn't exist. So instead of giving up your idea at that stage, you can use this tool and come up with alternatives. So friends, using all this innovation thinking, the good news is actually when it comes to EV, we talked about the battery being expensive and the cost of EV is high. Actually, there has been a 90% drop in the cost of storage of electricity in a lithium-ion battery, 90% reduction in just the last 10 years. So that's a kind of breakthrough innovation that have happened in this space. And 90% is not very common. It's a very, very rare phenomena, but we have been witness to this, and which is what is going to make EVs very affordable going forward. We didn't have much time to talk about the autonomous and connected vehicles, but there is just one innovation that I want to touch upon here. The LiDAR, which is a laser device, which is the eye of the autonomous car through which the car actually sees what is around, used to weigh around 13.5 kgs and used to cost, it was very, very expensive. Today, through a series of innovations, the LiDAR is something so small and compact that you can carry it on the palm of your hand. And the drop in the price in the last 13 years is 99% drop. What was $70,000 today? We are talking about sub $1,000 today. And that is the eye of this vehicle that we are talking about. So we are talking about an electric, autonomous, connected, and shared vehicle. If battery is important for the electric, the LiDAR is very important for the autonomous. And we have seen a 99% drop in the price of this in the last 13 years, thanks to all the innovative thinking that has happened in this space. So friends, when you decide to innovate in building mobility products for the future, you have 3 times more chances to be successful because the traditional automotive industry is now expanded to include the infrastructure, which is the roads, charging infrastructure, everything out there, and also the energy and the power industry, because we are talking about renewable sources and smart grids and charging infrastructure. So suddenly the industry is become 3 times bigger than what it is. So as a product designer and innovator, your innovations can cut across all these three industries: the automotive, the infrastructure, and the energy and power. So that's a kind of opportunity that's ahead of you when you decide to build mobility products for the future. This is a great place to be in. So friends, what we talked about today is in terms of how do we go about building mobility products for the future and what kind of skills that we would need. And my thesis is that we need to take a Desi approach to the design of mobility products. And the 4 core skills that we need would be design thinking, exponential thinking, sustainable thinking, and innovative thinking. So I'd like to take a pause at this stage and wait for questions from you so that we can have a quick discussion around the key ideas discussed today. So I will stop sharing my screen so that we can go with the Q&A.
Thank you, Dr. Shankar, for a very holistic overview of the design of mobility products. I particularly like the system dynamics model. I was working on that long time ago.
That work was done with Professor Amit RK from IIT Madras. So he's an expert in system dynamic modeling. So we have a couple of PhD students working on that. So we can discuss more about it. Sure.
Yeah, my PhD was in system dynamics long ago.
Wow, so nice. Very nice.
Yeah. So before I open this for question and answers, just a quick clarification or information for all the participants is that the next talk in this series is going to be on 14th June. It is going to be by Professor George from Germany, and he's going to talk about something very, very unique, which is how to take the Bauhaus School of Design's inspiration to designing a microelectronics program, which they have done in their institution at both undergraduate and postgraduate level. So this talk is coming up on 14th. The details of the talk are available on the CREE website. So interested participants can register there. So now over to the Q&A part. There are a few questions in the chat. I'll just read out them and then we can go on to the audience. So the first question is, a lot of articles are published saying EVs are more pollutants, are creating more pollution than the present IC engines. What is your view on this? This is by Sani.
Sure.
So EVs potentially can create more pollution than the IC. So that's the question.
Absolutely. So here we use a concept called well-to-wheel to make sure that we are able to compare different vehicle technologies and different fuel options. So well-to-wheel means where you are bringing the energy from and where you are finally using it across the entire system. What are the efficiencies involved and where all the pollutions are happening. So when you do this kind of a holistic analysis, you do find that the electric vehicle is the cleanest and the most efficient and the least polluting technology that's available to you today. This is basically assuming that the electricity that you are using for charging is not coming from burning fossil fuels, but is coming from a renewable source like solar or wind. So a lot of research has been done around this. I can share with you some of the papers and reports. But personally, I feel that a battery electric vehicle would be the cleanest option and very close to commercialization too. So that way, I think this is the best bet when we look at clean mobility for the future. Sure.
A related question from Gaurav is that why do Indian automakers show restraint in moving towards hybrid electric vehicles when they are supposed to be more environment friendly?
Sure. So look at this. A hybrid basically has a small engine, then it has a battery, then a motor. So when the battery uses up all its energy, the motor is going to run with one of the fossil fuels and then again charge the battery. That's the battery will transfer the energy to the motor, the whole thing will run. So this would make this, you would need a configuration like this when there are no charging stations around. Because when you run out of energy in the battery, there is no place where you can go and charge. But tomorrow, if we have a reasonable charging network of charging stations in India, then we won't have this constraint at all. And so it's a stopgap solution till the charging infrastructure is built. Also, when you are carrying all these three, the engine, the battery, and the motor, you are carrying additional weight. And the cost of the product is also going to be higher since you are paying for all these three key subsystems. And just like we leapfrogged Bharat Stage 5 and directly moved from Bharat Stage 4 to Bharat Stage 6 for automotive products in India, the aspiration here is to directly move from IC engine vehicles to a fully battery electric vehicle rather than go through the intermediate of a hybrid. Maybe if we had done this 10 years back, we might have looked at it. But today, actually, the batteries are so good that one can look at a direct leapfrog to a battery electric vehicle. So that's an opportunity before us today.
Okay. The next question is, you talked about deep sea mining. So there is a question, does deep sea mining not lead to new environmental issues?
Absolutely, we have to be careful about that's the blue ocean economy policy that India has created actually addresses a lot of these environmental issues. It has been so carefully drafted that we'll be able to use the resources from the ocean without really having any negative environmental impact. So as I said, as product designers, we all need to exercise sustainable thinking in everything that we do. So we have to definitely look out for if there is any inadvertent impact that we may be creating on the environment through any of these steps. And we have to eliminate those steps through the innovative thinking piece, which is the last part of the discussion today. So sustainable thinking and innovative thinking go hand in hand.
Yeah. Next question is from Umang. It says, where does academia in India stand today in creating relevant engineers for Industry 4.0? Issues and strategies by Mahindra to hire or groom engineers to stay competitive in the global world?
Sure. I think well, it's a very important question that Umang has brought up. And I think, Sudhir, we have discussed about it on a couple of occasions. So, for example, whether it's Industry 4.0 or the electric mobility, what the industry needs is engineers who are multi-skilled. For example, mechanical engineering, electrical, electronics, basic programming skills, and design skills. So it's very difficult for universities to train students in all these areas in the 4 years that they spend in a typical undergrad curriculum. So typically what happens is this is where the industry academia collaboration comes in, where the industry starts working with the universities so that during the 4 years that the undergrad student spends in the university, they are actually exposed to all these cross-functional engineering domains and also given the necessary design skills. So they become fairly industry ready by the time they pass out of these universities. Of course, we, as the Dean of the Mahindra Technical Academy, whenever we hire new students, we take them through a very rigorous 3 to 6 months program, giving them all these skills before they start working on real world projects. So, but the key thing here is in the past, depth was given a lot of importance. Today, the breadth is becoming as important as depth. So we need to train students with a reasonable amount of technical breadth also going forward. Those will be the best product design engineers that the industry would benefit from.
Thank you. The next question is from Shyam. It says, what are prospects of battery standards so charging stations will work as battery exchange stations?
Sure. So standards are evolving across all countries. Even in India, we have battery standards and also the charging standards coming up. But today, the battery chemistry, the LFP, the lithium iron phosphate that we use, current vehicles is spread across the entire floor of the vehicle. It's a fairly big battery pack, so it becomes very difficult to swap. But going forward, which could be in the 3 to 5 years time frame, when the solid state battery comes in, a solid state battery would be a lot more compact and it can store much higher energy. So there possibly we can look at swapping the battery. So where we can replace the battery in just a couple of minutes and then we can go ahead. So this time spent on charging, that constraint will go away very quickly if we realize solid state batteries. And that's a hope going forward that we'll be able to come up with swappable batteries because charging will take time.
Yeah, there are a couple of questions related to battery. One is on battery safety.
Yes.
Or when can we have 100% safety on battery
Sure.
kind of thing?
So
Second
there
one
are
is
three approaches to
recycling
battery safety. Yeah, go ahead, Sudhir.
Yeah, second is the recycling of battery materials.
Sure. So there are three approaches to the battery safety. One is the structural, where you don't, since it's on the floor of the vehicle, and if you're driving on bad roads, something can actually damage the battery pack. So one is giving the structural safety. Second is the thermal safety. You don't want the temperatures to rise beyond the temperature so that you can avoid a thermal runaway. The third is the electrical safety because it's a high voltage box that you're sitting on. So you want it to be sufficiently insulated from the rest of the vehicle. So all these three have come a long way. Today, we have very safe design of battery packs today. And the battery management system, the controls and actuators are extremely good, very reliable today. And a lot of quality controls have come into the battery, thermal battery pack management. Everything is pretty good today as compared to a few years back. Still, you see some incidents mainly on the two-wheelers where they may go for a cheaper battery which doesn't have all the safety mechanisms in place. But otherwise, the typical battery pack that we use in four-wheelers are pretty safe and it's been pretty good. In terms of recycling, it's super important for us to come up with battery designs that are recyclable and reusable. Batteries do have a second life. After they serve in a car for say 5 to 10 years, you can remove the battery pack and use it in a home inverter for another 5 to 10 years. That's a kind of juice the battery pack still has in it. And after that, when you go for recycling, as I mentioned to you, companies like Redwood Materials can actually recover almost 90% of the battery materials. So these are typically metallurgical processes that help you to get the lithium, cobalt, nickel, manganese, all these things out of the battery very safely. And that's also a good business opportunity for India, where they can actually recycle batteries and make it completely a sustainable process. So battery recycling is a big business going forward. Yes.
The other question is around hydrogen as an alternative to EV. What are your
Yes.
thoughts on that?
Hydrogen is definitely a clean fuel. Just like we talked about tailpipe emission, zero tailpipe emission for EVs, there is nothing, no emission at all from a hydrogen too. So where we are looking at adoption of hydrogen maybe is for the long distance trucks and buses. So India, just like we have multiple languages in India, we'll have multi-fuel and multimodal transportation because that's a kind of solution we need in India. So hydrogen will definitely have its role to play. But today it will take some more time to have onboard storage of hydrogen and also infrastructure to supply hydrogen across the entire country. All this will take some more time. So as and when it is ready, we should be able to use it. So from Mahindra's perspective, we have demonstrated hydrogen on a Scorpio vehicle almost 15 years back. We do have the technology, and whenever the market is ready, we may be able to look at it. But currently, our focus is entirely on battery-powered electric vehicles, nothing else as of today.
So I think more or less we have covered the questions.
Sure.
We have also exceeded by 10 minutes. Maybe I'll leave it to Sub for
Yes.
asking
Just
other questions.
a quick question, and thank you very much for your talk. While being in the other meeting, I have been eyeing your slides here and there. The question I have is, as you move towards battery, the number of people required to produce these vehicle reduces considerably. Whereas if you have hydrogen, then you can still modify the existing IC engines to work with it, and thereby not a radical change. Well, there are changes, of course. Still, there is still a possibility of using hydrogen in IC type engines as well, isn't it?
So I'm not an expert in hydrogen, honestly, but when I look at it from an EV perspective and I look around what is happening, actually there is an expansion in terms of hiring and jobs. We are creating new centers, for example, software-defined vehicles, and when we bring connected and autonomous along with electric, a lot of new jobs are getting created. But what is important is we need people with new skills to get into these new jobs. So as long as the skilling is done, I think there will be a lot of job creation that happens when we move into electric, connected, and autonomous vehicles. And my knowledge of hydrogen is very limited for me to very accurately compare the two. But personally, I am very convinced and excited about the transition to electric. So almost my entire focus is only on that right now.
Thank you. I think we are already 10 minutes past, and we let this go until everybody has a chance to ask their questions and go through this. I hope everybody enjoyed the presentation, and we would like people to join future talks. And the next talk is by Dr. Jörg Schulze from FAU. And from Fraunhofer Institute, he's going to talk about how they have created an educational program from the undergraduate to PhD for production of semiconductor chips. And I think that would be a very interesting program for everybody to see, given that India is thinking, again, jumping into the semiconductor space more and more, and how the educational program can be, that educational program could be a very good model for our discussions in the future.
The speaker from Germany.
Yeah. Sudhir, you can close it whenever you're ready.
So thank you all the participants, and thanks to Dr. Shankar for taking his time and then sharing his perspective on the mobility design with all of us. We look forward to more such interactions and also reaching out to more people within the Indian as well as the global context to bring them into this forum so that all of us can get to understand different perspectives and also practice and come back and share those perspectives in this forum. Right.
Somebody asked a question about whether Mahindra will provide support and guidance to undergraduate students. And I think that is something you should take up.
Absolutely. We are doing and we'd be more than happy to extend this. Surely, yes.
Thank you, everyone.
Thank you. This was excellent.